So thank you very much for that introduction. And thank you all for being here. So I'm going to talk about this integrated waste management and landfill engineering and sustainability perspective. I wanted to give a brief overview on waste management and landfill engineering. I understand that there are a lot of students here. I think you need to know what's going on in terms of this waste management field. So hopefully this will give you a lot of ideas dealing with waste management and the role of landfill engineering. So this is going to be more general talk. Then if you are interested in any of the topics, you can go into my research papers and find papers on it. So before I get started, I want to thank Ramaiah Institute of Technology for their invitation to visit this place. As I mentioned, I've been to IASC many times, but this is right next door, but I never got a chance to step here. It's a pleasant surprise that you guys have a very beautiful campus. So very nice facilities and bright looking students. That's the best part about it. So I want to thank the management, principal, and particularly head of the department. I've been talking to him for many times, and it's always a pleasure, sir, for inviting me over here. And I want to thank all the hard work that is being done by faculty members, to organize this one. And I want to thank my fellow colleague from IIT Madras. And as you saw, he is very dynamic, and he's making my stay at IIT Madras very dynamic. Like, you got only today, but I have every day for, so not in a negative sense, in a very positive sense. He's a very, very good. And, I enjoy his company in IIT Madras. Just, for your information, I have been at IIT Madras for the last 2 months. As an adjunct professor, and I'm going to be here until end of July. And I'm also US Fulbright scholar, so I'm doing the double duty as a adjunct professor and as also Fulbright scholar. So I enjoy my stay at IIT Madras. I never had a chance to work in India, so I used to visit 1 week, but attending a conference, you don't get the feeling of how it is like working in campus and dealing with the students, dealing with the fellow faculty members and all those things. So I'm learning, how it would be like if I had worked in worked in India rather than in the US. And I want to thank all of you for attending this in spite of your other schedules. So I'm from Chicago, and anybody who has visited Chicago, it's a very beautiful place to visit. Our HOD sir has visited recently. He can testify that I'm not faking. So this is really true, especially in the summer. It's very beautiful. We have a very good lake, and especially if you are a civil engineer, this is an example of what civil engineers can do for infrastructure and the environment. And the last two photos you see are my campus. So I am in charge of these two labs, Sustainable Engineering Research Lab and Geotechnical and Geoenvironmental Engineering Lab. Just to give you an idea about types of research that I do. I do a lot of research on environmental remediation of soils, sediments, groundwater, and stormwater. So I develop the technologies to address the pollution. And I also work on waste management and landfill engineering, which is the topic of my presentation today. But I have a lot of specific research questions that I answer through my research. And then for last several years, I've been working on this life cycle assessment and sustainable and resilient engineering. So in this one, I'm more interested in developing the sustainability analytics. Everybody talks about sustainability these days, whether they understand what it means or not. It has become a buzzword, but my research is about quantifying the sustainability. How do you quantify? If you say, your system is sustainable, how do you say that one? How can I calculate the sustainability metrics and then show that? So not only sustainability, there's a resiliency has become very important. And you need to think about both of them. Resiliency is, especially to the climate change impacts, is extremely important. So having the frameworks, and once you have the frameworks, you can apply to anything that you are doing. You know, it doesn't have to be geotechnical or geoenvironmental. It can be structural engineering, you know, water resources, anything that you can apply. So, and I actually, you know, I teach a course on sustainable engineering for graduate students, and I have students from electrical engineering, chemical engineering. They come and take the course. They learn, you know, what are the sustainability principles and metrics and tools, and they apply to their designs. You know, for example, last semester I was teaching the, you know, the one project that electrical engineer did was substation design. How do you make it more sustainable substation design? Of course, you know, my master's and PhD were in geotechnical engineering, and my undergraduate is in civil engineering. So these first two topics that you see, those are, I call it a geoenvironmental, and this is more sustainability. And geoenvironmental, I'm passionate about this topic of geoenvironmental engineering. I want to, it's not used very commonly. It's a combination of, you can say, you know, easy way is combination of geotechnical and environmental. Kind of, you need to bring both of them together. But if you think broadly, it is much more than just geotechnical and environmental. You need to have a background on chemistry, hydrogeology, microbiology, some kind of a medical, environmental justice, economic issues, like looking at the systems engineering approach, and the environmental laws. So, and then we address all these issues: environmental characterization, risk assessment, containment, remediation, waste management. So to address these environmental issues, having geotechnical background alone or environmental engineering background alone is not enough. So you need to, you know, encompass all this multidisciplinary things. So I would say geoenvironmental engineering is the application of all relevant multidisciplinary background to create a holistic engineering solutions, right? That's the problem that we see. You know, people work in their silos and they're not able to come up with a holistic solution to the problem. So the problems are not being solved. So then geoenvironmental problems is basically waste management, polluted sites, sustainability, and resiliency. So this is a truly multidisciplinary technical approach. So I really enjoy working on this one because it has a huge practical impact. And if you want to know more about this field, you can read my paper. So, and you know, over the last 25 years, we have been working on a lot of different aspects of sustainability and geoenvironmental. We have 4 books, many journal papers, many conference papers. You know, if you want to get into details, you know, you can go into this website and find the information about these publications, okay? So I just take opportunity, you know, in presentations, what my research philosophy is. You know, this is very important. What we do is we identify a real world problem. We really, you know, identify what is the problem that we are facing in the society. And then we come up with a research hypothesis. What could be the potential solution to the problem is? And then we want to test it out, right? You know, that's the scientific approach. So we do the bench scale experiments. These are very easy and not time consuming, not expensive. So we do that one. And if we find the positive results, then we scale up. You know, everything is not tiny, right, in experiments. So you need to scale up. And we do that one in our labs. And then mathematical modeling is extremely important because, you know, once you do these experiments, you can understand what are the fundamental processes that you need to be modeling, and then incorporate all those processes into mathematical model. And then you can scale up with the modeling to the field scenario. You cannot apply it directly from lab to the field. You know, you need to have a mathematical model to be able to design the field systems. And I also love going to the field and demonstrating or testing our hypothesis, what we found in the lab, because anything that works in the lab, even large scale, may not work in the field. So, you know, if it doesn't work in the lab, you know, you don't need to go to the field. You know, you don't have to spend time. But if it works in the lab, then you want to go out and see if it works in the field or not. So I love, you know, working with the students. You know, these are all the pictures with my students. So the concept that I have is, you know, we are in the university. We need to advance the fundamentals. Nobody, you know, practitioners are not interested. They are really, you know, trying to implement the solutions to the problem. So we advance the fundamentals. At the same time, we are trying to solve the real world problems. So that has been my motivation for doing any project that I do. So the students get excited that, you know, we are trying to solve a real world problem, and then we need to do that one on a fundamental basis. So this is my a lab. I do a lot of experimental research. So of course you need to have the infrastructure to do this kind of experiments. So we have all these experimental facilities that we have. And these are the students I guided over several years. And these students come from different parts of the world. Being in the US, we get the best students from all over the world. And you see many Indian students included here. And it's a pleasure to go to my lab, to work with these students coming from different countries, with the different languages, different cultures, different food things. We talk about technical stuff, but we also talk about this, cultural stuff. So which makes it really, really, exciting. So I hope, I can see some students from Ramaiah Institute of Technology included in this picture in the future sometime. So if any of you are interested in going for PhD, just please feel to contact me. I would be happy to. Of course, I have a very good experience with the Indian students. I have no problem taking students from places like this institute. Okay, thank you. So let me get into the presentation outline. So it's going to be very general, especially, I kept the students in mind and wanted them to think, this whole problem in a holistic way. So I'm going to talk about the issues, current strategies, and dumps and landfills, and then, tell you, what could be the ideal solution to this problem, sustainable integrated waste management, okay? So that's at the end, one slide of closing comments. So I'm going to, my slides are very simple. So, I don't need to spend a lot of time on each slide. So I'm going to, keep on moving. And if you're interested in getting copies of these slides, let me know. I will be happy to provide these slides. So globally, this waste generation is going to be a problem going into the future. It's going to be a huge problem. As you see from here, projections of this waste generation is going to be very high. So right now we are creating 4 million tons per day, right? And, as of now, but it's expected to double or even triple. Even with the waste that we are generating right now, if we have issues, think about when the waste is going to be doubled and tripled, right? If you say that, oh, we have all this waste dumps problem, then, think about, when the waste is going to be doubled and tripled, what we're going to do with this one. And it's not, just in India, all over the world, the quantities of the waste are increasing. The simple reason is population increase. The population is increasing everywhere. And as a result, the waste per capita is increasing. So everywhere, this waste is going to be increasing. So this is, going to be a huge problem as we go into the future. The waste composition changes from place to place, just looking at the holistically, the average. So you can see, the food and green waste and glass, metal, paper, cardboard, plastics. This again varies from place to place, but this is kind of a typical composition of the municipal solid waste that we are looking at. So what are we doing, right? What are we doing with this waste? Globally, if you're looking at World Bank information, so composting is done, incineration is done, controlled landfilling is done, but a lot of things are in open dump and some recycling that's going on. But most of the waste is being dumped in open dumps or landfills that are not operated properly, uncontrolled, landfills. They call it landfills, but they are actually not landfills. So, all the countries have realized that this is a huge problem. You have environmental agencies, right? In the US, we have US Environmental Protection Agency. They are after protecting the environment. They are supported by the taxpayers' money. So they have, guidance on what needs to be done in terms of the regulations and also enforcement activities. In India, you have a Central Pollution Control Board. I always tell, people that first thing that you need to look at it is what are the regulations that are being proposed. And unfortunately, there's one thing, the regulations are there and practice is different, right? The regulations are written, but how much people are following, that's an important thing. So you need to look at these things. And I think if you have come across this waste management, you might have seen this hierarchy diagram. So basically, you want to have prevention, minimization, reuse, recycling, energy disposal, energy recovery, and disposal. So landfilling or dumping is the last option that you can think of. So you need to understand all these things. Even though I may be working on landfills, but you need to think about what are all the other things that can be done. So at the end, I want to come to this conclusion that one thing is not going to solve the problem. You need to have a combination of these things. So that's the message I'm going to end up with. Okay. So the problem is, people are looking at, okay, this one solution is going to solve the problem, but one approach is going to solve the problem. That is not the case. So pollution prevention is, first of all, you don't want to create the waste, right? How do you create the waste? Basically, how do you, prevent creation of the waste? So this basically, you have to look into the manufacturing and what materials that are using, what processes that you are using, and so that you're not really, generating the waste. So this is, there are a lot of things that you can do, from environmental point of view, or also from sustainability point of view, looking at, using the less reagents, less toxic, chemicals, minimizing the energy use, using a lot of renewable materials and so forth. So this is practicing the green chemistry, using from materials that are green. And then, there's a green engineering concept. The sustainability is beyond the green engineering, but in the green engineering, you try to do these best management practices so that you don't generate the waste. So, that's the one thing. And this requires a thinking. You have a process to follow right now, but what are the alternative processes that you can think about? So that kind of awareness should come. So, how much solvents I'm using in a process, how much aqueous solutions, and how much input I have, and then how much waste that I'm generating. So this is the 4 different processes that I can follow to create the same product, but you want to use the one that is going to produce the less impact. So this has to come from the manufacturers. So now move to minimization, right? So, if you cannot prevent it, try to minimize as much as possible. Again, this falls into the hands of the industry, manufactures a lot of these products, and they need to do a lot of things in terms of redesigning their processes so that the waste is minimized. So then, if you cannot prevent it, minimize it. If you cannot minimize it, then at least the waste that you generate, maybe can you reuse it? And this is where a lot of efforts are being done. So you reuse, clean, and use the materials over and over again. So, for example, what are the advantages of this? For example, if you have an aluminum can, right? And to make that aluminum can, you have to use so much of energy. So if you recycle, you are conserving that energy, right? So it's obviously a very simple concept. So all the materials, when you recycle, so you are avoiding the, energy to make them, if you have to make them new instead of recycling. So reuse is just using the material as it is, and recycling is, again, you can do the pre-consumer or post-consumer. You can manufacturers can use internal waste, and post-consumer, kind of external waste, and a lot of industrial byproducts are there. In the US, we have these material recovery facilities. All the waste goes to these recovery facilities, and they sort it out. And I think in some countries they will have dozen different bins, and they ask people to sort it out. But in the US, we have only 2. One is the non-recyclable waste, and it's a recyclable waste. And the recyclable waste goes to this MRFs, they call it. And there, we use the technology and personnel to sort out and do that one. So, one of the problems with the recycling is that we used to recycle and ship everything to other countries like China, Philippines, and other places. But now they are not accepting our recycled material. So then the problem is, if you recycle and if you don't have any uses for that one, it's becoming a problem. The piles of these materials are lying out. So think about it. You want to recycle it, but at the same time, you need to think about whether that recycled material is going to be used or not. Because in the US, we have piles of these recycled materials. They are becoming a nuisance. It would have been nice not to recycle them. So, and then a lot of people in the US are environmentally conscious. The food waste is one of the things that can be easily avoided disposal. So, composting is done. So I'm showing this picture. You can go to a regular store and buy this one. Walmart, you can buy this one for less than $100 or $200. And then you can put it in your backyard, and whenever you have food waste, put it in there. And it creates the nice compost, and then you can put it in the backyard and a lot of people do that. There are many uses for recycled paper. Recycled paper is not a problem. There are many ways that recycled paper is used. The plastics, some of them can be used, but a lot of them cannot be recycled, and they end up in the environment. They pose a lot of problems that you are aware of. Beaches and all different places it comes out. And recycling is very important in civil engineering. For construction, we use a lot of materials. Construction industry uses a lot of materials. And if you look at, what is the demand for construction materials going into the future, if you look at the sand, gravel, and crushed rock is going to, double by 2060, the demand for the sand, gravel, and crushed rock. I mean, you have seen construction everywhere, right? And we are running out of the sand, and you're already experiencing a lot of places. So how do you deal with these things? So you really have these, waste materials that can be reused in construction purposes, okay? Construction has to, continue, and you don't have those natural resources. So the only thing that you have is this recycled materials. So we do a lot of research in our lab. So, for example, I showed you the pictures of these different types of materials that we worked on in my lab. One thing that I want to mention is, there are a lot of other people all over the world are working on reuse of recycled materials. But the problem is they just do some characterization studies, and they don't take all the way to the end application. So you really have to follow this kind of protocols. You identify what materials and what applications, and then you establish the lab testing methodologies, because standard testing methodologies that have been used for soil and concrete may not be useful, depending upon the material that you're dealing with. You need to establish the testing protocols and do the tests, and then look at the results. Are they applicable? If they are not applicable, then don't give up. Maybe there's some modification that you can do, and then make sure that the material meets the requirements and the approval requirements. And in this testing, not only the mechanical properties, hydraulic properties, but also the chemical characteristics. One of the main thing is leachability. So a lot of these waste materials might have contaminants. So when you have rainwater or something, if they are leaching all the contaminants, that is going to be a huge problem. That also needs to be analyzed. And then you do the field demonstration, and then you create the specifications and do the sustainability assessment, and then make it guidelines for people to use it extensively. So it's kind of you have to follow all these steps. I see a lot of people working on geotechnical characterization or chemical characterization, and not bringing all that knowledge into field application. So that's the thing that you need to provide. And there are a lot of barriers for recycling, and that upcycling is actually you're branding the material as something going to perform better than any other alternative materials that you have for that application. So the public awareness, policy and regulation issues, market issues, logistical issues, these are going to be a huge challenge, but some materials are now being accepted in construction very easily, and there is a shortage of those materials. So a lot can be done by civil engineers in different disciplines. Energy recovery is one thing. In the Indian context, there's a lot about having waste to energy plants and making all the waste to disappear. All these waste dumps disappear overnight, right? I don't know. Maybe I'm dramatizing it too much, but I think I hear in the news that having the waste to energy plants is going to solve this waste problem. That's not the case. So I'm giving you examples of this waste to energy incinerators that are there, but in the US the number of these are going down extensively, because first of all, waste has to be conducive to the burning. If you have too much of, water or, too much of, inerts, it's not going to be good. So, it has to meet the requirements. It has to have a caloric value. And if you don't have it, then, you cannot get any benefit out of it. And then you get, ash out of this one. So that needs to be managed also. Ash will have a lot of toxic metals. So you need to think about that one. The other important thing in these plants is air emissions. So you see 1, 2, 3, 4, 5 here I'm showing. They're all different types of emissions that get emitted during the process. And especially the dioxins are carcinogenic, highly carcinogenic. Small amount of exposure will cause the problem. So I would be really worried living right next to any waste to energy plants, within several miles of it. So, and with the case of it. But you need to, in Europe, they use these things. It's not anything new. In Europe, they use it because they have, they implement the technology to control the emissions. So, it's going to cost a lot of money, but the technology is out there. So there are a lot of, advantages. Just I want to mention this one in terms of incineration. The waste to energy is basically incineration. Reduce the volume. You don't need landfills, low water pollution problem. So all these things, there are benefits, but at the same time, you need to look at disadvantages too. So this is not easy. Yeah, there are a lot of shortcomings, especially making sure that your waste is conducive to the burning, and also looking at the emissions in addition to high costs of these treatments. And then I found a newspaper articles that there is an air pollution problem by these waste to energy plants in Delhi. And there are protests about this. So as in the opening remarks, Professor Venugopal sir mentioned that you need to think about 3 things. Even Professor Devagowda also mentioned that we need to think about soil, air, and water. This contaminant transport. You have to see this holistic system, because if you transfer the contaminants from one phase to other phase, solid to liquid or solid to gas phase, is not going to be that's not going to be solving the problem. So you need to look at the holistically everything. So last thing is disposal. So open dumps, right? We don't have any open dumps in the US. If you have to find an open dump in the US, it's impossible to do that. But there are a lot of things in India, right? So I got pictures of these dumps in the newspaper articles. I subscribe on Google News, Landfill. So I get a lot of news about landfill situations, dump sites situation in India. So I get to read the news articles, and whenever there is a photograph, I grab those things. So the slope instability and failure. I mean, everybody who has taken soil mechanics and geotechnical engineering, the slope stability, you have to maintain it. You cannot have some vertical slopes. So people, when you are dumping, you dump without any proper slope. So there was a case in Delhi that it slided, 2 people died, but in other places people live right at the toe, and a lot of people, hundreds of people got killed. The other problem is toxic gases and odors, right? I mean, in the US, we have at least a control on what goes to a landfill, but in India, everything goes there. Even probably hazardous waste is also going there. And then, in US, we have generally methane and CO2, but here you could be having a lot of toxic gases that's coming out. It's just not a methane and CO2 or H2S, but you have a lot of these, the toxic gases that's coming. And you have seen this news recently, right? Even landfill in Chennai has the fire, and one in Delhi, they keep on burning, and burn like 3 days, 4 days, they will extinguish, and then the problem is subsided, and then again it comes back. It's this is really bad. And then you leach it. All the water that falls on the waste, going to come out, and it's going to contaminate the river, lakes, all the things. And that leachate has a lot of toxic stuff. If you are, taking the water from those contaminated waters, it's going to be a problem. The problem that you don't see is that a lot of chemicals get into the groundwater, and then it passes through in the ground flow with the flow of groundwater, and you have contaminated groundwater, and you have a drinking water well in the groundwater. you may be drawing the contaminated water. So you need to really think about, and then if it is a river, it could be entering into the rivers and polluting the, the fish and other things. So it's going to be a huge problem. One thing I really, feel sad about is the people living around these dump sites. I know in Delhi, they are right next to these dump sites. And some of them work as scavengers. That's their livelihood. And there are demonstrated studies on very bad health of these people. That's, I think, social injustice or so-called environmental justice, is extremely important in this kind of cases. And a lot of, newspaper studies. So what are the regulations, right? I just looked at Indian regulations, Central Pollution Control Board regulations. They tell you this one, reduction of the waste by biomining and waste processing, followed by placement of residues in a new landfill or capping, right? So I don't understand what this biomining is and how do you process it and how you use the residue. It's, and if the residue is contaminated or not contaminated. But in my view, this is quite challenging. Biomining and handling of the residues is quite challenging. That is not. What we have done is the capping. And in the even Indian regulations say that this capping is, is an option, right? And then, the capping, basically you put a cover on the top of it. And then, so this is the regulations. You can find it in Central Pollution Control Board information. So what can be done, right? So what can we do for these dump sites? So I want you to think about what is the solution to this problem, right? So one of the solutions is this, right? The solution is, okay, can we, segregate and reuse, right? Can we segregate and reuse? This is one option, okay? I'm going to go through several options that you can have, and you need to think about it. This problem is going to persist for a long time, and it's going to become even worse and worse. A lot of the civil engineering students now, in the future, if you want to follow, environmental career, so you have to address these legacy dump sites that we're going to have it. So one option is, okay, why don't we, take a, equipment there and try to sort it out. And there are a lot of issues with this one. It's not easy, right? And you think about people who have to work on this segregation and what is the value for the segregated products? That's, and the other thing is, can we excavate and incinerate? That's the big thing, right? And that's what being proposed. But that's not a problem. That's also not a suitable solution because waste conditions are unsuitable, as I mentioned. And then you have toxic emissions. And what is the net environmental benefit? We have to use the energy to burn it, and you're going to recover some energy, but what is the net environmental benefit of doing this one? That's another issue. So this is also questionable. And then why don't we retrofit landfill slope stabilization, right? This is kind of easy. So you can create the geometry that you want so that you don't have the problems of slope stability. And then you need to look at the landfill gas collection, right? So because you have, when the waste degrades, you get a lot of methane production. And the methane production, if you have some igniting source, that is what is causing the fires. The fires are due to these methane gases. So you need to have gas collection systems, and then the leachate I mentioned, you need to have a certain way to collect that leachate, because if the leachate goes into the neighborhoods or contaminates the groundwater, you could do some things like tow drains or leachate control and collection treatment systems. You can put this one at the systems. But then, you're dealing with the waste. What about contamination in the subsurface, right? So if the groundwater is contaminated. If the groundwater is contaminated, we have a technology called these vertical barriers. These are called slurry walls. And these could be constructed, okay? I know, of course, it's going to cost, and Professor Duragowda said, like, India is not poor, so we can, spend some money and build these things, and it's going to, benefit the future generations, right? So we can, let's say, if the groundwater is contaminated, we can build this containment walls. Basically, you dig a trench and fill it with impermeable material, and then groundwater does not contaminated groundwater does not pass through it. Or this can be, horizontally, how it is arranged. That wall can go all around the waste, or can be down gradient of the waste. Or you can pump out the groundwater and then treat it. This is a little bit expensive, but using the biological methods is much more better. So you can use the bioremediation of the contaminated groundwater. So I'm trying to, think about the solutions to the dump problems. Okay, what can you do? So you have to deal with the waste that you have, and then you have to deal with the contamination that you have at the site. Or there is other solution is called the permeable reactive barrier. So you can put a trench, but you have to put a permeable material in that as the contaminated groundwater passes through it and it cleans up. Okay, so you need to look at this thing. The other thing is, once you have the waste, you have to put something on the top of it. Otherwise, it looks ugly. And then, whenever it rains, all the water goes through it, and all that becomes the contaminated groundwater. So you don't have to, there are multiple options for covers. You don't have to make it very expensive cover system. So you can do research on this one and develop a more sustainable cover system that does not allow the infiltration of the precipitation, and also, does not allow the escape of the gases. That can be done also. Again, the civil and environmental engineers or geoenvironmental engineers can do these things. And, as I said, like we can think about something out of the box. A lot of, you don't have geomembranes, you don't have soil available, and these sites are really big. Maybe can we use some of the waste materials in this cover construction, make it, sustainable cover system. So you're solving the environmental problem of the dumps. At the same time, you are using the waste that otherwise would have required to dispose. So I think this is one project called biochar, which comes from bioenergy production of the biomass. So that can be done. Once you close it, what can you use it for? As I said, we don't have dump sites. All the landfills have been closed, in the US. Even the new landfills, we close them. And then the land is not idle, right? So we create the parks. So you can see all these beautiful parks. They are, old landfills. So, and then you can use these things for golf courses, recreational parks, or even putting the solar panels and so forth. So very nice. So the dumps, we should not be having dumps. So we need to have an engineered landfill. Going into the future, one thing that amazes me is that in Indian context, you're trying to take away these dumps, right? How much you're doing? They're trying to do some, mining and taking it out. They're taking 2,000 tons or whatever per day. But 3,000 tons of new waste is coming to the landfill. Same dump. How is the problem is going to be solved? Right? Somebody should just think about it. I see the statements, oh, in 3 months, this dump is going to disappear. But, you're just only using, processing less waste than the new waste that you're coming in. And, the dump is going to continue. So the new waste, at least we need to have some engineered landfills. And engineered landfills is not a, new technology. It is very well-established technology. We have been using it in the US for 3 decades, and, Europe has done it. So you need to have a final bottom liner, final side liner, leachate collection system, and the final cover system. So, these systems are, the design procedures for these are very well established. And you need to have a gas collection system and leachate collection system. So you are addressing the problem through entirety, waste contained, and then leachate is being removed, gases are being removed. So, you get a good containment. So I actually, wrote a book in 2004. In this book, I talk about the design of landfills, very, very systematically. So, what I'm trying to say here is designing a landfills is not a rocket science. It's very well established. And then the only thing that I want to mention is that whatever being done in the US or elsewhere, you don't have to do it. As long as you make it a performance-based criteria, not like, specifications that are used in US, you need to, use the materials that are locally available and make it. So these pictures, we go to the landfill sites. I go to these landfill sites all the time. And this is, the industry knows how to build it, how to operate them. This is a liner and leachate collection and removal system. So I love going to these dump sites. I have, I know researchers in India, they do research on landfills or waste, but they've never been to a landfill. because it's stinky, right? They don't want to even step down. I mean, I happened to go to one of the landfills. I mean, imagine there was a fire, there was a leachate, and there are cows, birds, smelly. It's, worst case, but in the US, it's much, much cleaner. So we go to the landfills. And then, once everything is followed, it's closed, and then your final cover is put on. This is one landfill close to my town. It's a golf course. Rich people will come, pay the money, pay the golf. And you're generating the money. And looks beautiful, right? Who says that this is a dump site, right? So we have a means to do all these things. But there are still some challenges of engineered landfills. In the US, even after we design, engineer, we're trying to make it these more optimized. So there's a problem with the slow degradation of the waste, leachate treatment, fugitive gases, sustainability. These are the things that we are addressing. So if I say that landfill things, everything is established, there's nothing to work on it, but there is a scope for doing the research. So these are the kinds of research projects that we are working on. I'm going to present one on this leachate recirculation in the afternoon. That's a kind of a new technology where we are actually, landfills are being converted as in situ anaerobic reactors. So this is the bioreactor landfill where we inject the leachate and degrade the waste really fast. I'm going to come to that one later on, and you can do the landfill mining. But in the US, we don't have that many landfill mining projects. The problem is it's a very expensive process, and you don't get the valuable products out of this one. Only few places they do mining where they wanted to recover some space to accommodate the new waste. So that's the other thing. So the landfills have advantages. Here is the advantages. Nobody wants to have a new landfill in their neighborhood. NIMBY syndrome, right? Not in my backyard. Nobody wants it, right? That's the biggest problem of siting a landfill. Even like incinerators, there's a lot of opposition. But landfills have a more problem than. And there are disadvantages. So nothing is perfect in this world. So there's advantages and there are disadvantages. So it's not having landfills is not a perfect solution to the problem. So all these things that I mentioned, prevention, minimization, reuse, incineration, landfilling, if you think about all these things, they have pros and cons. Okay, even if you want to follow this hierarchy, still we have a problem. So the solution to this problem is we need to think about in combination all of them. So I don't like this hierarchy. I don't like this hierarchy process that you see in a lot of textbooks. This is not a good approach. What is the good approach is this one, integrated waste management, IWM. What it is this, okay? We need to embrace all the options, okay? First thing is you want to collect and sorting or segregation. That's, is very important. And then material recycling, then biological treatment, then thermal treatment, then landfills. So you really need to have a combination of these options. So how do you select these options, right? So I don't know if you do the sustainability things. So so-called, life cycle assessment is the methodology to assess the broader environmental impacts. So this is what I'm showing you here is the integrated waste management options. So you use the inputs, and then by using this assessment, you get outputs, right? So you can assume different combination of these options for your site, and then look at this baseline scenario, what you're doing now compared to different integrated waste management strategies. How much of recycling that I want to have it. So these are kind of typical results, how much collection and sorting I want to have it, how much biological treatment I want to have it, landfilling and recycling. So you can assume different scenarios and then model it and see the impacts. Which one is the best option to provide the net environmental benefit, right? So that's how, we need to think about it, incorporating the sustainability. It's not one thing, it's a combination of the things that really depends upon the location. It's not like, for India, just one solution is not a problem. Even Bangalore could be one solution. Mysore could be another solution. So really need to look at, the site-specific situations. So you can, look at this one. But sustainability is, this life cycle assessment is this environmental aspects. But we need to think about social aspects and economic aspects. These are very important, right? So this is where we call it sustainable waste management. You need to look at environmental, economic, and social. So this is what I always like to promote in terms of this waste management. We need integrated waste management, but we need sustainable integrated waste management. What does that mean? So we have these combinations, right? Inside that you see the combination of these things. I told you, you do the life cycle assessment and then see which combination is good. So that is looking at the only environmental aspects. But you need to look at the economic aspects. How much is it going to cost? And you also look at the social aspects. If people in a particular neighborhood, they're hungry, right? You want to provide the food for them, not look at this integrated waste management and spend a lot of money for that, right? So you need to look at the social aspects, economic aspects, and the environmental aspects, and come up with the combination of these strategies that would be useful for a given situation. And then landfills doesn't have to be just the dump yards, okay? So you can think about those as in situ treatment facilities. So you build a cell, and then you treat it aerobically or anaerobically. You can try to degrade the waste, and then degraded landfill, you can take it out, mine it, and then you kind of recycle it. So basically what I'm trying to say is, in environmental engineering or chemical engineering, you have reactors, right? So you take the waste material in a reactor and degrade it and then recover the product. Same thing like this. Instead of doing in a container, you are doing it in the field, and then degrading the waste, recovering the gas, recovering the leachate, and then finally reusing the same site. So you're basically maximizing all the benefits of this one. So this is the last slide. I just want you to think about this option. So one takeaway point from my presentation is this word same waste management strategy as Bangalore? No, right? That's where the social, economic, the sustainability aspects come into the picture. So there's no one silver bullet or silver solution to this solution. And then for a younger generation, this dumps problem is going to be there, and we need to really solve this problem. This is sad to see in this modern era having dumps like that, and they're going to cause a lot of problems. So we need education, communication, and enforcement to make things really happen. And especially the students can make it happen in the future. So you might have heard the word circular economy, but circular economy actually deals with the waste management. So right now, we use it and throw it in the landfills or incinerators. So this approach of reusing the materials again and again, and not sending the waste to landfills and incinerators. That's basically circular economy. So using the materials, putting into the use all the time, and never sending to a landfill or incinerator. So this is the term that you're going to hear a lot, circular economy. It's nothing to do with the dollars or rupees, but it's doing the circularity of the materials used, okay? So thank you so much. This is my contact information. You will, happy to, take questions later on if you have it.
The floor is open for question and answers. You can ask.